Hello everyone, welcome back to This Is Not a Science channel, and let's talk about science today. And this is our second chemistry video, and I'm really excited because this is when we actually get in the chemistry. We will be talking about atomic structures and the periodic table, which is pretty iconic for a subject like chemistry. When someone said chemistry, we thought of the periodic table, the elements, and the chemical reactions. So let's just get straight into it. Alright, so I wanted to start off this topic with a slightly general question. What is an atom? So when I speak of atom, what is the first thing that came off your mind? I'm pretty sure the majority of you would want to agree that atom is actually the smallest component in life. Well, that is not really the case. Now we're going to look deep inside how an atom actually looks like. So this is how an atom looks like if we manage to simplify it down. And it might be slightly different from what you imagine, but the general structure is still there. So you can see in the center, the red bit, it's the nucleus, and the nucleus is surrounded by shells, and shells are filled with electrons. And it's important to remember that the first shell always has 2 electrons. So you cannot be more than 2. It's always just the maximum number of electrons for the first shell is 2, and for the other shell would be 8. Now I'll introduce 3 new materials that actually make up an atom. So in fact, atom is not the smallest thing. We have even smaller components that actually build up this atom. So I just want you guys to try this first. So we have that previous picture of an atom, and would you just try and label this atom like as much as you can. So try to label as much feature as you know. Okay, so I hope you guys managed to label most of the features of this atom. So now let's just get into it. So we got in the center, which is marked red, that's the nucleus. And surrounding the nucleus we got shells, and on the shells, like orbiting on the shells, we got these crosses called electrons. So these are the main components of an atom. But hold on, where is proton and where is neutron? Well, if we want to learn more about protons and neutrons, we have to zoom in inside the nucleus. So a nucleus is basically a ball, a clump made out of protons and neutrons. So we can see the black ones here, they're neutrons, and whereas the red ones here, they're the protons. So they actually clump together to form the nucleus. And then we have these shells surrounding them, which has electrons orbiting around them. This together forms an atom. Now let's actually get in the properties of these 3 basic components that made up an atom. So I would like to introduce this table here, which is really important. So we got here protons, neutrons, and electrons, and we have their mass, their charge, and their location. Well, okay, first of all, we have to know, which is very important, that protons and neutrons, they're both in the nucleus. So these are the 2 components that made up the nucleus, whereas the electrons, they're actually orbiting around. So they're on the outer shells, they're orbiting around the nucleus. Right, so now let's get into the mass. So what you have to remember is protons and neutrons, they both have a mass of 1. So comparing these 2 together, they have around the same mass, whereas electrons, the mass is almost 0, which is around 0.0005, which is almost negligible. So we can just call it electrons having 0 mass. And when it comes to charge, this is where it's important, because these 3 components, some will have charge, some won't. And these charges will be very important in future chemical reactions, where you guys will see how a charge will actually affect a behavior of an atom. So we can tell from here, protons have a charge of +1, whereas neutron has no charge. So that's why it's called neutron, which neutral means that it doesn't interfere, it doesn't have any charge on it. And electrons, which is pretty opposite to protons, they have a -1 charge. So this leads us to some wordy rules. I'm sorry these are really dull, but then you really have to remember these in order to master atomic structure. So let's just get into it. A neutral atom will always have the same amount of protons and electrons. Well, this makes sense because if we look back at the table, we see protons have a charge of +1, whereas electrons have a charge of -1. So if we want to have a neutral charge, which is 0, we have to have the same amount of protons and electrons where the charges cancel out. So +1 minus 1 equals 0. The second rule is the number of protons determines the atom. That is correct because what makes one type of atom so special is because every single element have a different number of protons. And this leads us to atoms of the same kind might have different number of neutrons. So which means they have the same number of protons, so they're still the same elements because they have the same number of protons. But actually they have different number of neutrons, and we call these isotopes. So you might see this type of atom, these two atoms, they both have the same number of protons, so they are the same element, but they have different number of neutrons, so we call these isotopes. And another one is atoms of the same kind might have different number of electrons. So that means they have the same number of protons, they are still the same element, but the number of electrons are different. So we call these ions. And this is when stuff gets interesting, because we talked about before where a neutral atom has the same amount of protons and electrons, which actually balances the charge to 0. But now we see we have different number of electrons, which means the charges are unbalanced. So in the future, when you see atoms with a charge, it's very likely for it to be an ion, where it has the same number of protons, but they have different number of electrons. Now let's actually get into how to use a periodic table. How do we actually understand it? Because this is actually really interesting. We can get into different types of elements and we can get into different types of reactions. Right, so we need to start by understanding how do we read an element. So we can start from looking at the symbol of it. So the symbol here is Na, and the name would be sodium. So that's the element symbol in its name. Well, this number on the top, 11 right here, it will be the atomic number, and this is extremely important because what makes an element special is its atomic number. Every element has its unique atomic number, and it's all different. So for example, in this case for sodium it's 11. And another important thing to remember about atomic number is the number of protons will always equal to the atomic number. So we see from here the atomic number is 11. Then we must know that the proton number is 11. That's just the rule. And we also know proton number will equal to electron number. So the electron number would also be the same as atomic number. So from just looking at this, we can know that atomic number is 11. Therefore, the proton number will be 11. Therefore, the electron number will also be 11. And this number below is what we call relative atomic mass. Basically just a fancy word on how heavy this atom is. Right. And here we go. We got a series of ways to work out. So if we want to know the proton number of an element, we can simply look at the atomic number. So in this case, the proton number of sodium will be 11. Whereas if we want to work out the electron number, we look at the proton number, which is 11. So we know this thing has 11 electrons. And when we take a look at neutron number, this is a bit different. If we want to work out neutron number, we have to take a look at the relative atomic mass. We have to take the relative atomic mass and minus the atomic number to get out the number of neutrons. So in this case, it will be 23 minus 11, where we work out the neutron being 12. And how does this work? Well, in the previous table, we mentioned how neutrons have a mass of 1 and protons have a mass of 1 as well. So if we have 11 protons and the total mass of this is 23, then the rest of the mass must belong to the neutron. So let's just do a small practice here. Here we got 3 different types of elements, and I just want you to work out the number of protons and electrons and neutrons for these atoms. So based on the rules on the previous slide, I simply want you to work out using these rules here, work out the electrons neutrons, and protons for these elements. So just pause the video now if you want to give it a go. I hope you had a try on trying to identify the proton, electron, and neutron numbers for these three elements. Now I'm going to reveal my answer right here. So for magnesium, you should get 12 protons because we know the atomic number is 12. Therefore, the proton number must equal the atomic number. And the electron will equal proton number, so we have 12 electrons as well. Whereas neutron will be the mass number minus the atomic number, which is 24 minus 12, we get 12 neutrons. And the same case is here for oxygen, where we have 8 protons right here. So that means the atomic number is 8, therefore the electron number is also 8. And when we need the neutron number, we take the mass number 16 minus 8, we get 8 for neutron. Whereas uranium is slightly more challenging because we have a huge number here. Well, we always start with the atomic number. So let's take a look at where is the atomic number here. Okay, it's the 92 right here. So we immediately know the number of proton is 92. And once we know the number of proton, we can tell the number of electron because they are the same. So we know the electron number is also 92. When we want to work out the neutron, we just have to take the mass number minus the atomic number. So 238 minus 92, we get 146. So that will be the neutron number. This finally took us to the periodic table itself. So the periodic table looks intimidating. There's a lot of information on it, and it's almost impossible to comprehend every single thing. Well, we have to break this down. So for me, I would like to break down this table into 3 major sections that you need to know. So we'll start with these ones here. These ones on the left hand side, we call these the metals. So they are solid and they're shiny, so any traits that you can thought of a metal having, they're on the left hand side. While the right hand side, I'll call these the non-metals. So these are the gases, gases or liquids or semi-metals, something like carbon, which is not really a metal. It's a sort of soft material. And we have here in the middle section, which I would like to call these the transition metal. And these are really interesting. And I'll explain in the future why these are called transition, because their properties can actually change quite a lot. And another important thing about the periodic table is we have to understand these numbers here on the top. So we got 1, 2, 3, 4, 5, 6, 7, 8. And these ones means the one coming down. These are what we call the groups. So if we look down vertically, this one will be group 1. This one will be group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Whereas these number here represents the horizontal rows where we call it as a period. So we have period 1, period 2, period 3, period 4, period 5, period 6, and period 7. So this is a faster way to quickly identify an element from the periodic table. And unfortunately, I have to call it to an end here because there's still a lot more information about the periodic table and the actual atomic structure we will cover next time in our next episode. So make sure you stay tuned to the next episode to learn about why do we group them like this? Why do we have groups and periods? They actually make a logical sense. So yeah, I guess that's all for our part 1 periodic table introduction. And I hope you like this video, and I hope you subscribe to my channel and then share this to your friends who hate science. Make sure you stay tuned, turn on the bell after you subscribe so you can get my next video as soon as it's released. So the next chemistry episode we will be talking about the continuation of this periodic table topic. Thank you very much and see you next time.